Welcome to another new episode. Like always, today we are here with an exciting topic that will boost your knowledge. So, without further ado, let's jump straight into the main discussion.
Welcome to This Explainer. You know, the universe is packed with wild stuff, but honestly, nothing really comes close to the invisible giants lurking out there in the dark. Today, we're diving straight into the science, the history, and the absolute mind-bending reality of black holes. Now, our source material actually gave us a pretty fun challenge. It asked us to explain this whole concept using a simple story like we're talking to a 5-year-old. So, let's run with that for a second. Picture the universe as this incredibly vast, pitch-black forest, and we are on a hunt for invisible monsters hiding among the trees. Don't worry, they aren't scary monsters. They're just forces of nature that our eyes literally cannot see. We're going to figure out exactly how to spot them, how they get so massive, and where they're hiding right this very second. All right, let's kick things off with Section 1. Meet the invisible giant. Imagine a cosmic vacuum cleaner. But not just any vacuum, one with a gravitational grip so unimaginably intense that absolutely nothing can escape it once it gets too close, no matter how fast it's moving. So, formally speaking, a black hole is a spot in space where gravity is so strong that not even light can get out. It's a mind-bending idea, right? It all goes back to Albert Einstein's general theory of relativity. Because they trap all light, they are what we call perfect black bodies. They reflect zero light back to us, which is exactly why they are completely invisible against the dark backdrop of space. Now, quantum mechanics does suggest they might slowly leak an incredibly weak form of energy called Hawking radiation. But actually, scratch that, it's so unbelievably faint that our current technology couldn't even dream of detecting it yet. So if you're picturing this invisible monster, you can think of the event horizon as its front door. It is the absolute outermost edge of the black hole. The rule of this cosmic giant is pretty simple. You can walk right up to the property line, but the second anything crosses that event horizon, there is no turning back. Literally, it is the ultimate point of no return. The gravitational pull just becomes so overwhelming that escape becomes physically impossible.
Moving right along to Section 2, a math idea becomes real.
You know, scientists didn't just point a telescope at the sky one day and stumble over a black hole. They actually predicted them on paper centuries before we ever found one. It's wild to look at how these giants evolved. Way back in the 1700s, guys like John Michel and Pierre-Simon Laplace were tossing around this crazy idea of objects with gravity so strong that light couldn't escape. Fast forward to 1916, and Carl Schwarzschild found the very first mathematical solution to Einstein's equations for a black hole, which we now call the Schwarzschild metric. Then in 1958, David Finkelstein finally explicitly defined it as a place in space with zero escape. Things really kicked into high gear in the space age, though. In 1967, Jocelyn Bell Burnell discovered neutron stars, proving that these bizarre, superdense objects could actually exist out there. And then, boom, just a few years later in 1971, scientists found Cygnus X1, the very first actual black hole ever discovered.
For the longest time, a lot of people thought these invisible beasts were strictly imaginary. You know, just fun, abstract puzzles for physicists to solve on their chalkboards. They genuinely didn't think black holes were real objects. But eventually, the evidence just became undeniable. The math was right. Scientists realized that yes, they are very real, very hungry cosmic entities that are actively shaping the universe around us.
Which brings us to Section 3, how the giants grow. So, how exactly do these beasts get so massive in the first place? Well, they're typically born at the dramatic end of a really massive star's life. When one of these huge stars dies, it collapses under its own gravity to form our invisible giant. And once they're born, they start to feast. They get bigger by gobbling up whatever happens to be nearby: gas, dust, even whole stars. They can also grow by colliding and merging with other black holes. And in some special cases early in the universe's history, they might have even formed directly from the sudden collapse of unimaginably huge clouds of gas. And when they eat enough over billions of years, they become what we call supermassive. Guys, these supermassive black holes are just mind-boggling in size. We are talking millions of times more massive than our own sun. And scientists actually agree now that these absolute giants, perfectly camouflaged in the dark, aren't just rare oddities. They are hiding right at the very center of practically every single galaxy in the universe, acting as the anchor for all the swirling stars around them.
Okay, let's head into Section 4, following the footprints.
This brings up a pretty major puzzle. How on earth do we find an invisible monster in a dark forest? Well, we do it by looking for their glowing footprints. See, when matter like gas or dust falls toward a black hole, it doesn't just drop straight in. It swirls around it really fast, forming this spinning ring called an accretion disk. The intense friction in that spinning disk heats the material up so much that it glows incredibly brightly. Sometimes, this process creates a quasar, which is literally one of the brightest things in the entire universe. So while we can't see the black hole itself, our space telescopes, like Chandra or XMM Newton, can easily spot these massive blazing footprints lighting up the dark.
And let me tell you, it is incredibly messy when a wandering star becomes a giant snack. It happens in a few dramatic steps. First, a star just gets a little too close to a supermassive black hole. Second, that overwhelming gravity doesn't just gently pull the star in. It physically tears the star apart into this brilliant, glowing stream of gas. It's violent. And finally, that glowing gas is swallowed up across the event horizon, forever. By watching these spectacular destructive light shows, scientists know exactly where that invisible giant is sitting.
But we don't always need to catch them eating to find them. We can also just watch how stars move. If astronomers see a group of stars orbiting incredibly fast around what looks like completely empty space, they can use math to calculate the mass and location of that invisible spot. If the mass is high enough, it definitively proves it's a black hole and not just another dense object like a neutron star. Think of it like watching a group of kids dancing in a circle holding hands with an invisible friend. You can tell exactly where that invisible friend is and how strong they are just by watching how the kids are being pulled around.
All right, last part. Section 5. Monsters in our neighborhood.
Let's bring this whole story a little closer to home. Right at the center of our very own Milky Way galaxy, there's a supermassive black hole named Sagittarius A star. Scientists have carefully tracked the star zooming around it, and they figured out that this monster weighs a staggering 4.3 million times more than our Sun. 4.3 million. It is just silently sitting out there, holding the center of our galactic neighborhood together.
But here's the thing. They aren't just hiding in the center. The closest known stellar black hole to Earth, a guy named Gaia BH1, is hanging out just 1,500 light-years away from us. Now, 1,500 light-years might sound far, but in cosmic terms, that is practically just down the street. And that leads us to this truly staggering estimate from NASA. Based on everything we know about how stars live and die, there could be anywhere from 10 million to up to 1 billion stellar black holes silently hiding in the Milky Way right now. Let that sink in. Up to 1 billion. Millions of invisible giants drifting through our cosmic forest, totally unseen by the naked eye.
So with millions of these invisible giants hiding right here in our own galaxy, it really makes you wonder, what else is waiting to be discovered out there in the dark? Every single time we build a better telescope or refine our math, we pull back the curtain on another cosmic mystery. Keep looking up, keep asking questions, and never lose that wonder about the beautiful mysteries of the cosmos. Thanks for joining me on.
How did you like today's discussion? If you have any questions about this topic, don't forget to let me know in the comment. Stay well, stay healthy.